All right, class, in this video we continue our discussion of section 4.6 in your textbook on modeling with exponential functions. And so we're going to, in this video, cover the example on page 3 of your lecture handout. You're given a certain culture of a bacterium. Initially has 35 bacteria and is observed to double every 6 hours. So the initial number of bacteria is 35 and the time to double is 6 hours. So in part A, you're asked to find an exponential model of the form n of t equals n0 times 2 to the t over a power for the number of bacteria in the culture after 6 hours. And so, as already stated in this problem, the initial number of bacteria n0 is 35 and the time for the culture to double in size is 6 hours. So replacing n sub 0 with 35, down here we replace n sub 0 with 35 and replace a up here with 6. So this is our model for this particular problem, right? 35 initial bacteria and the time to double is 6 hours. So in part B, you're asked to estimate the number of bacteria after 14 hours. Well, to do that, we just put in 14 in for t, and we have n of 14 is equal to 35 times 2 to the 14 over 6 power. 14 divided by 6 is equal to 2.333333. And now you got to follow order of operations. Got to do exponentiation before multiplication. 2 to 2.333333 is equal to this number in parentheses, and then you multiply that by 35, and when you round to the nearest whole number, you get there are 176 bacteria after 14 hours. In part C, you're asked, after how many hours will the bacteria count reach 1 million? Well, here's our model up here, right? And so we're asking, okay, if n of t is equal to 1 million, how long, right, what's the value of t? So we're asking how many hours before we have 1 million bacteria. So we replace n of t with 1 million. Now we're going to solve for t. So first thing, right, you isolate the exponential. What undoes multiplication? Division. So we divide both sides by 35, and we have 1 million over 35 is equal to 2 to the t over 6 power. And now I'm going to take a little different approach to solving for t from the previous example, just to illustrate there's more than one way to solve for t in the exponent. If we take the common log of both sides, right, we have the common log of this fraction, 1 million over 35, is equal to the common log of this exponential, 2 to the t over 6 power. Well, you know from the laws of logarithms, we can apply the power rule to the right-hand side here, right? We're taking log of 2 raised to the t over 6. This exponent, t over 6, can be brought down in front of the log, and we have t over 6 times the common log of 2. On the left-hand side, this fraction, 1 million over 35, is equal to this number right here, 28,571.4. Okay. Now, we're solving for t. So we divide now on the right-hand side, right? We have t over 6 times the log of 2. What undoes multiplication? Division. So we divide both sides by the log of 2, and then when I switch to two sides of the equal sign, I have t over 6 is equal to log of 28,571.4 over the common log of 2. Continuing on, using your calculator, the common log of 28,571.4 divided by the common log of 2 is equal to this number here, 14.80228555. And then in solving for t, multiply both sides by 6, and we get t is equal to 88.8 hours rounded to the first decimal place.